All right, hello once again, Jeff Scott of Rankin Technical College. We've been talking databases, and I do want to mention to you, all right, that this is probably going to be the only chapter in the book for which we won't go back and actually look at a bunch of examples, all right, because this is a more an introductory type of chapter. When you work with relational databases are based off of relations and relationships. It's these relationships that link together your different relations or your different tables. There's three primary kinds. There is a one-to-one relationship, a one-to-many relationship, and a many-to-many relationship. Just so you know, to start with, the nirvana. So what we're striving for is one-to-many relationships. That's what we want. All right, relational database management systems can handle many-to-many relationships. You get around that by creating one of those join tables like we looked at earlier, or junction tables. What a one-to-one relationship is, let's suppose for a second, and I'm making this up off the top of my head, but let's say we created a table, and that table had in it first name, it had last name, it had address, it had city, it had state, it had zip code, and it had cell phone number. All right? So we've got 1, 2, 3, 4, 5, about 7 fields. Now someone in their infinite wisdom comes in and says, you know what, we're going to have in here employee number, employee department, employee salary, all right, employee supervisor. Let's leave it at that. Now we've got probably close to a dozen fields. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fields. All right. So someone comes in and says, you know what I really would rather do is take this and have 2 tables. All right, I'm going to add here, we'll just call this ID, and that'll identify the person. But somebody comes in here and now comes in and adds an employee ID field, and then puts here the employee number, the employee department, the employee salary, and finally the employee supervisor. So what I've done is I've taken a structure that could have been set up with just one, all right, table, and I put it into 2 tables. One of them we'll call this person, which is kind of a silly name, but you get the idea, and this will be called employee. So these would be 2 different tables, all right? And this might be the exact same field, which is fine. But when you have a one-to-one relationship, what that means is every one element in this table has to be associated with just one element in the other table, and that's what we have. So typically, what happens when you get a one-to-one relationship is you take a table that's starting to get big and unwieldy, and you break it up into more than one table. But what they're saying here is in a one-to-one relationship, every one record in one table is related to at most one record in the second table. And every record in that second table is related to at most one in the first table. All right? Now, one-to-many. Let's use our same example here and now talk about one-to-many. All right, I'm going to break this up and I'm going to add another table. I'm going to call that table department. And in my department table, I'm going to have 2 fields. I'm going to have a department ID, and I'm going to have a department name. all right? Just those two fields. Now what I can do is, rather than specifying that employee department, and let's assume for a second with the departments we have things like shipping, receiving, accounting, payroll, and there might be a lot of other ones. So this one is going to have, like for example, might be 01 is shipping, 02 is receiving, 03 is accounting, 04 is payroll, etc. Now what I'm able to do is, rather than put the employee department in here, I can put in here employee ID or employee department ID. So now I'm going to have a single number in there as opposed to putting this in there all the time. Okay? If I put that in there all the time, so that's in there in a lot of ways, I might spell receiving wrong once. I might decide to abbreviate it RCVING or whatever, all of which would be an error. Okay? So this is a one-to-many relationship, and what that means is, for every one department has 0, 1, or more employees working for it. But every employee has only one department that they work for in the example that we're going to set up. So that's a one-to-many relationship. There's also a many-to-many relationship where any one record in the first table is related to 0, 1, or more in the second table, and every one record in the second table is related to 0, 1, or more in the first table. Now, they give you some examples of this on the bottom of page 11 and going on to page 12. I just gave you my own examples, so I'm not going to go over those. But I do want to mention, because I already said it in the note that's here on page 12, relational database only support one-to-many relationships directly. You can have one-to-one, you can have many-to-many, but for many-to-many, you need that junction or join table. They also mention on the top of page 13, they talk a little bit about a word that's referred to as cardinality. And that's the minimum number of tuples or records that must participate in a relationship. If each tuple in one relation must have a matching one in the other, it's said to be mandatory. All right? On the other hand, if we start a brand new department at our company, okay, so let's just say that we just started a brand new department here. So we've got shipping, we've got receiving, we've got accounting, we've got payroll. Now we add an IT department. And that becomes so successful, we add a web department, let's just say. Well, we added that web department, and there aren't any records in it yet, because there are no employees that have been specified to work in web. So that would be an example of having one relation that does not require a matching tuple in the other. And under these Ask the Expert, like they show here on page 13, the author tries to bring some of this stuff, kind of bring it together, for lack of better words. So they have you do a normalization exercise right here. And they talk about what's wrong with this. Okay? Well, the first thing that I see that's wrong with this is we've got a field called category, and that field called category has got each one of the, not each one, but 1, 2, 3, 4 or 5 of the examples here for our category have multiple values. When you have multiple values like this, those are referred to as repeating groups. You can't have that. That cannot be handled correctly in a relational database management system. So we take this and we break it up into its own table. We've got category ID and category. All right? You'll see this if you take a look at the answers that are at the end of the book. The rest of this chapter is a prelude, or it's more discussion about SQL. And they mention, while this whole thing is based off of the relational model, SQL is what supports the physical implementation of the database. SQL is a non-procedural language. When you talk about some programming languages like C, COBOL, and Java, they're procedural. So you have to specify exactly how something has to be done. When a language like SQL is non-procedural, all right, then it's concerned with how, not with the how something is done, but what is being done. And they mentioned that in here again. They don't use the exact same verbiage that I use, but it's pretty much the same thing. A little more on the history. We talk about the SQL evolution. I'm just going to jump onto the next page because they show a timeline as far as what's going on, and we realize with this timeline it only goes through around 2006 because that's when the book was written. They mentioned on the top of page 17 here that RDBMS, Relational Database Management System vendors, typically put their own spin on SQL. It's what makes their product unique. These are referred to typically as vendor exceptions. All right. And the author talks here about something that's referred to as the object relational model. Today, with the advent of object-oriented programming languages like Java, C#, etc., many people felt that there was a need for object relational model, sometimes called, instead of RDBMS, OORDBMS, Object-Oriented Relational Database Management System. All right? It is an offshoot of writing regular SQL. I'm not going to go into it any more than that. All right. 3 major types of SQL statements, 2 of which I've already mentioned to you. The first are DDL, Data Definition Language, and they are the keywords create, alter, and drop. I already showed you those. They working with the database schema. All right? Again, they work with the database schema. And what that means is they work with the underlying database objects. Okay? So they allow you to create a database, alter a database, drop a database, etc. The data control language, that we're not going to deal with in here because we're always going to log in as though we were the root administrator. Okay? So, but if you're not, that involves setting up rights, granting, revoking rights, etc. The data manipulation language, DML, those are I went through this with you also before, and that is select, if we want to just look at or read data, insert to add new data, update to change existing data, and delete to get rid of existing data. All right, they talk about types of execution. We're going to be using it here, direct invocation. We're going to communicate directly with our application. There is also more that are shown on the top of page 20, embedded SQL, module building, and CLI, which stands for call level interface. Doesn't matter what those are because we're not going to use those. Another Ask the Expert here on the bottom of page 20. Do want to mention that the author, at times at least throughout this book, puts a gray box in like this, where he will come in and talk about just different topics, give you a historical chronology or whatever. So a relational database management system is a program or set of programs, so it's software that allows you to store, manage, retrieve, modify, and manipulate data in relational databases. Examples include Oracle, Microsoft Server, or SQL Server, IBM's DB2, and MySQL, and there are plenty of others. In addition to complying with SQL standards, most of these relational database management systems support other features. Some are graphical in nature. We're going to, at first, with what we do in here, we're going to be working with non-graphical. Then we're going to get into graphical as we go on. Now I'm going to skip this next section because, again, they just show you what some of these look like. It'll make more sense to have us look at what we're going to look at under the guise of what we're going to be working in. And we're going to get into that in the next chapter. So that pretty much is it for the current chapter. And again, what we went over here is kind of a brief history of SQL, what SQL is about, and we looked at SQL, but again, from a very general perspective. We will come back in just a couple minutes. We will go into Chapter 2, which starts in your book on page 29, and it's on working with the SQL environment. So I'll be back with that shortly.